All right, let's go over the answers to the quiz. Um, all right, so I made it out of 26 points. It's like 1 point per blank is what I would have done if I was grading it. Finding the first five terms, -5, 10, -15, 20, and -25. You just start by plugging in a 1 into n and then a 2 into n. All of that. You definitely should have commas because it's a sequence, have commas in between. Finding an explicit formula, it was arithmetic, where the first term was -7 and the common difference was 4, and I plugged it into the formula, and I got that the nth term is equal to 4n minus 11. You should have the nth term there. Finding the next four terms of this sequence given recursively, well, your first term was 3, but then the second term would just be plugging in a 3 into 2 times 3 minus 5. It'll give you a 1. Third term would be plugging in the 1 into the an minus 1. So you got -3. Fourth term would be plugging in this -3 here into for the an minus 1 to get -11, and then the last one is -27. Given this sequence, what's the recursive formula for it? So a recursive formula, you're going to give the first term, which is 1/2, and then each term is obtained by just multiplying the term right before it times 1/2. And so it was an minus 1 times 1/2, and that's for n is greater than 1. And then it's just standard to just stick that 1/2 in front of there. So you need the an equals 1/2 times an minus 1. And then you need the n for n greater than 1. Finding the explicit formula, I plugged in both that the fifth term is equal to the first term plus 5 minus 1 times the common difference, and that the eighth term is equal to the first term plus 8 minus 1 times the common difference. But then they gave us that the fifth term was 10, so I plugged in a 10 on this left-hand side. And they gave me that the eighth term was 2, so I plugged a 2 in there. So I ended up having these two equations, and you want to solve for the common difference. And so I subtracted the second equation from the first, got that your common difference is -8/3. And then you plug it into one of these equations, doesn't matter which. I chose into this first one that 10 is equal to a1, the first term, plus 4 times that common difference. And I got that the first term is 62/3. And so plugging that in, you get this. The first term plus n minus 1 times that common difference. And then that simplified down to that the nth term is 70/3 minus 8/3 n. Those are decimals that keep on repeating, so you should not have given me a decimal answer. I don't care for improper fractions, so if you would have said, what is that? 20 something and whatever over 3. Not a fan. I like improper fractions like this. And then to find the 12th term, you just plug a 12 into n, and you should have gotten -26/3. Again, you should not have given me decimal answers. If you did, I would have taken off the point because that's approximations. Those aren't exact. Determining whether the sequence is arithmetic, geometric, or neither. This first one, we're multiplying by -1/2 to get to each term, so it's geometric, and your r is -1/2. This guy, you added 4 to get to the next term, so it's arithmetic, and the common difference was 4. It's neither if it's not geometric nor arithmetic. That's how you would, if you're not multiplying by the same number each time, or you're not adding or subtracting the same number each time, then it would be neither. Finding 3 arithmetic means between 64 and 82. I drew 3 blanks, and I ended up getting that this common ratio going in between there is 9/2. So I gave exact of 137/2, 73, and 155/2. This one, the decimals do terminate. So if you wrote 68.5 and 77.5, that is fine. Finding the mean proportional between -8 and -14. Remember that they need to, when you're finding the mean proportional, you need to match the sign. So it would have been a negative inside there. And you just take the negative of the square root of multiplying the two. And I left it as an exact -4 rad 7. If you put -10.6, you're not really right, but I probably wouldn't have deducted the point, but just know, like, it'll be an exact answer. when you take a test. Using sigma notation, two different answers, and I wrote them down here. I found that the common ratio was -4. Your first term is 0.2. So totally fine. What did I use? Either choose an N or a K, Mrs. Bright. Apparently I chose both, but whatever letter you use for the index down here needs to be up there. This one is just plugging it straight into the geometric formula for the nth term, first term times the common ratio to the n-1. If you do that, then you need to start with 1 down here. Go into infinity, because of the dot, dot, dot. If it starts with an index of 0, then it needs to be just an n up there. But either one of these answers are correct. Your book most of the time used starting at 0, like your book would match this answer. Totally fine answer to have that one as well. So just know that you need to be able to, when you plug a 1 into n, that you get that first term. That's how you're going to double check whether or not, like when you're looking at the multiple choice questions on the test, we won't give both of these. It'll be one or the other. How do you know which one's right? Plug that 0 in, and does it give you the first term? Plug the 1 in, and does it give you the first term? And that's how you can verify which one. Finding the partial sum of this guy. So S sub 9, so you're finding the first 9 terms and adding them up. This was arithmetic, right? And so I did n over 2 times the first term plus the last term, or the 9th term, and so I got 207. Using the binomial theorem to expand it, let me make sure the whole thing is on there. It's a lot of work, right? But you should have ended up with this answer in the end. If you had written like b to the -1 power and b to the -2 power, that would be fine too. There's nothing wrong with that. But showing this pattern, I did show the n choose r notation. This would be the same as 5 factorial divided by 5 factorial 0 factorial. But there's where you should have gotten your answer. Finding the 9th term. Well, if it's the 9th term, your x will have to the power of 6, because it would have started with 14 and then 13, 12, 11, 10, 9, 8, 7, 6. So the 9th term, that power on x is to the 6th, and then the power on the -3y needs to add up to 14. So 6 plus 8 gives you 14. And then this is 14 factorial divided by 6 factorial, 8 factorial. And don't forget that when you do this, the -3 is to the power of 8 also. So it'll be a positive number. And you do 3 to the 8, and then which was 6561, and then I multiply that times the 3003. Determining whether the sequence converges, and then if it does, then find the limit. This guy, I just divided top and bottom by n, and so I would have a 3 divided by 2 minus 1 over n. Do you remember that 1 over n as n goes to infinity is 0, so you're left with a 3/2. Now, degree on top, same as the degree on the bottom, it's your leading coefficient. This guy is a geometric series where your r is less than 1, and so it does converge, and it converges to 0. Determining whether this series converges or not, well, your common ratio is 1/3. That is less than 1, so it definitely converges, and it's geometric, and so it converges to, you do the sum of 1 over 9, which is your first term, over 1 minus the common ratio, and so you end up with a 1 over 6. And why does it converge? Or because the common ratio is less than 1. That's what we're looking for there. If a ball is dropped, you're going to start with 40, and then remember what goes up must come down. So it's 2 times 40 times 0.7. And then on each successive one, you're multiplying times 0.7. So the 40 is not part of the infinite series, but all of this is. And so I did first term divided by 1 minus the common ratio, and then added it to the 40. You should have gotten 226.67 feet. Power series that converges to this guy, it converges to first term divided by 1 minus the common ratio. So you need a 1 minus something in the denominator. So I factored out the 3 to make that first term a 1, right? And when you factor out a 3 from negative 2x, it'll be negative 2/3 x. And then I bumped that 3. 10 divided by 3 is the same thing as 10/3 and then divided by this other guy. So now it's of the form of my first term is on top, the 10/3, and my common ratio is 2/3 x. And so just plugging it into, you could have done 10/3 times 2/3 x to the power of k, where k is starting at 0 and going to infinity. Also fine, this is a geometric, right? You could have also done, if you were starting with 1 to infinity, a perfectly fine answer as well, to the k minus 1 as your power. That would be fine as well. Perfect. Math induction. First one is prove that it's true for n equals 1. You're plugging a 1 into the left side and the right side, seeing if it's true. And sure enough, it was. Assuming that pk is true, just plugging a k into all of these n's. Proving that it's true for k plus 1, you start with this first statement. And then what I want is my very last step to show that 1 plus 3 plus 5 plus 2 times k plus 1 minus 1 is equal to k plus 1 quantity squared. And so I just needed to add, I added the very next term on the left-hand side, which is plugging in a k plus 1 into n. And then I added it to this, I added the exact same thing to the right-hand side. So adding the same thing, simplifying that, factoring it, you end up with k plus 1 quantity squared, boom. And then don't forget your booyah statement of, by mathematical induction, the above statement is true for all natural numbers. All right. I hope you all are having a fantabulous day. Bye.